official. Okay, so we're going to talk about systems of equations. This is review for most of you, but some of you it's new. I'm not sure who it's, is it new for you?
I think I've done this.
Okay, I think you did too, but it's new for Cassius, it's new for Naima, and everybody else has experienced this last, oh, and maybe Max, is probably new for Max. When we talk about, up to this point, we've been dealing with equations, right? We haven't been dealing with systems of equations, we've just been dealing with equations. So the question is, what's the difference between an equation and a system of equations? Does anybody remember? Like think about a stereo system. What's unique about a stereo system? What does a stereo system have?
I don't know, but maybe like the stereo system like is more complicated than others. Maybe.
Yeah, like a stereo system has a tuner, right? A receiver, I don't know what you call them nowadays, but whatever, and you know, like a radio kind of thing. You have speakers, you have speaker wire, you know, you've got a CD player, you've got a DVD player, you got surround sound, right? You got all this cool stuff, right? A system means more than one thing, right? There's lots of things involved. So when we're talking about systems of equations, we're talking about more than one equation. Okay? And when we ask you to solve a system, we're only going to be dealing with 2 equations. We're not going to be dealing with 3 equations or 4 equations or 5 equations or 6 equations. But you will, and you'll deal with some of those in Algebra 2. But in Algebra 1, we'll just deal with 2 equations, okay? But if you have an equation, every equation, we're talking about straight lines, okay? So one equation might give me this line. Another equation might give me this line, right? Where would you think the solution would be when they asked you to solve? Right in the middle, right where they both touch, right? And wouldn't you agree with me that the x and the y point, that this equation, if I plug that x and y into this equation, it would be true. And when I plug that x and y into this equation, it would be true. That's the same point. If that was 2 comma 3, 2 comma 3 is a solution to both of those points, those equations, those lines, right? So if I did something like, okay, so if I did something like this, okay, y is equal to x minus 3. And x plus 2y equals 6. X plus 2y equals 6. And I asked, find the solution of this system by graphing. Well, then I'd have to graph. I'd have to the reason why graphing is not really a great method is because you have to be outrageously accurate. And if you don't have grid lines from graph paper, it's really hard. Right? It's really hard. So we're going to hope that I do it close enough to accurate so that I can get an answer. So, right? So how would I graph this one? What? Is it somebody? Yeah? Sorry, Sarah. Okay. So first thing I do is I look for that, right? I go to -3 and put a dot. And then what's the slope? So from here I rise 1 and I run 1, dot. Rise 1, run 1, dot. Now when you're solving these by graphing, it's important to keep doing the slope. Okay? Rise 1, run 1. Rise 1, run 1. And just for a while, because somewhere you're hoping that one of those points will be shared with this one. Does that make sense? So now let's figure out this one. How would I graph this? This is in standard form. Yeah. So if I make y equal to 0, I'll find my x-intercept, right? X equals 6. So here I got 1, 2, 3, 4, 5, 6, right? So there's my x-axis, my x-intercept. I'm going to make x 0. Y is what? 3. Y is 3, positive 3. So 1, 2, 3. Okay, so I'm going to draw this line. I think I went too high on that. Okay, so I'm going to draw this line now between here and here. It looks to me like this is the point. Doesn't that look to you like that's the point where they intersect? Which is, what is that point? What is that point? The x is 1, 2, 3, 4. 4, comma 1. Now, that to me looks like the right answer, doesn't it to you guys? Now, the only thing is with graphing, you never know, so you have to check it. So that means I would come over, I would take my equation, y is equal to x minus 3, and I would plug this in. What is my 4 and 1? Which one is x and which one's y? Okay, so x is 4, y is 1, right? So I'm going to put a 1 here, because y, 1, equals x is 4, 4 minus 3. Is that true?
Yeah.
1 is equal to 1, that checks. Now the trouble is I have to check it with the other one too. I have to go back, I have to check this one too. Because I don't know, if it's not, if it doesn't work with one of them, it's not a solution to the system, right? If it does work with the first one, I have to check and be sure it works with the second one. If it doesn't work with the first one, I don't have to go any further because I know it doesn't work, right? It doesn't work with one of them, therefore it doesn't work with the system. But now I'm going to try this. X plus 2y equals 6, right? That's an equals. 4 is my x, plus 2 times 1 equals 6. So 4 plus 2 equals 6. 6 equals 6. It works. That's true. Don't you agree with me? So I know this point works for this because I got a true statement when I finished it. I got 1 equals 1. If I had gotten 2 equals 2, it would still be true. Or 9 equals 9. Or negative 13 equals negative 13. It would still be true. But if I got 4 equals 7, you see how that's impossible? You can't have 4 equals 7. Therefore, if that's what I got, then I would know it doesn't work. Does that make sense? That's how I would plug this in and see. Do I get a true statement at the very end? Make sense? We're not going to spend a lot of time on this one. But I just wanted you to understand, solving a system is looking for the place that's true for both equations. It's only one place. There's only one point. Does that make sense? And the trouble with graphing is a lot of times the answer is not right on one of those grids. You know what I mean? When you have a graphing grid, you know, it's ideally it falls right in one of those corner grids. But if it doesn't, if it falls right here, if it falls right here, oh my gosh, I have no idea what point that is. I could say, let's see, you know, let's say this was the y-axis. I could say, I don't know, 2/3, comma, 2/3, but it might be, you know, 11/14, comma, 11/15. I mean, there's an infinite number of possibilities that it could be. And I'd be guessing through the roof. Do you see what I mean? And so I don't want to be spending my time guessing when I'm solving a systems. Therefore, I don't use graphing very often. I only use graphing when I want to get a ballpark picture of what it looks like, or when I know that it's going to have an answer that's on a corner grid. So I can say exactly what that point is. Do you see what I mean? All right? I would hate to have to, if I thought that was the answer, and I thought it was 11, whoops, if it was 11/14, comma, 11/15, I would hate to have to substitute that into these equations. You know what I mean? It would be hard to solve and to verify whether it works or doesn't work. It would be hard. So I'd rather do an algebraic method, which is substitution. That's what we're going to spend our time on. And it's really quite simple and quite fun, really. Oh dear, this doesn't really erase very well. You guys understand what it is then? When I say solving a systems of equations, I'm just giving you two equations, and I'm asking you to solve for that place where they come together. And these actually have a lot of real-life applications, and we're going to do a bunch of them. We'll do a bunch of word problems eventually, where you're going to see how they really work. They're pretty amazing. Really. It's very, very useful. All right, so substitution. I guess I could just do one of the graphic. Sure, let's do this one. Here's our first one. We're going to do about 3 of them as an example, and then I'm going to give you the homework to work on. Y is equal to x minus 3, and y is equal to negative x minus 1.
Why are they singing?
What?
They're singing.
Like there's
It's
SpongeBob
really,
song.
it's really weird.
I don't know. I think they need ukulele backup.
Or maybe they just need to be quiet.
Oh, well, that's a good idea. Okay, so when you're solving by substitution, what does substitution mean? Does anybody know? Yeah.
Wait. Substituting something with another thing.
Right, exactly, right? It's like replacing one thing with something else that equals this thing, right? Substituting, right? Yes, makes sense? So you have to, this is the one thing you have to look for. Must have. Okay, one equation this on the line. Okay, good. Must say x equals or y equals. That's really important. One equation must say x equals or y equals. And if it doesn't, you have to make it say that. You have to manipulate it so that it says that. Number 2, the second thing you do is you circle what y equals or what x equals. You circle it. And the third step is you substitute that into the second equation. And it sounds harder than it is. It's really, really easy. The second equation. Okay? So, in this case, which one of these says y equals? In this case, wake up, Shelby. What? You're cold?
It's really
It's cold in here?
I'm
It's 69 degrees.
but it's really cold.
Oh my god. Anything under 72 is freezing.
Yeah, I'm just sitting here like,
Alright, we're going for 71.
thank you.
Thanks for telling me. Okay, I'm back. Alright, so which one of these says y equals? Oh, both of them. So it really doesn't matter. I could circle either one I want, right? I just have to circle one of them. I'm going to just circle this one. Notice I didn't circle the y. I just circled what y equals, right? Remember this? Do you remember this a little bit from last year? And now I'm going to go down. This is the same thing as y. Do you agree with me?
Yes.
Same thing. All right, and I know that at this point where those two cross, I know the y's are exactly the same thing, right? And that other one, it was 4 comma 1, the y was 1. For both of them, it was 1. So I know the y's are equal. Does that make sense? And the x's are equal at that point only, right? Yes? Yes?
Yeah.
Makes sense?
Yep.
Therefore, I know that since this equals y, this also equals this y. So I'm going to circle this y, and I am going to replace it. I'm going to substitute this y with that, right? Remember this? Now you remember. So now your equation, instead of writing y here, I'm going to write the x minus 3. So x minus 3, and then equals negative x minus 1.
I remember these.
Yeah, and so the cool thing is, I have now, up here I had two different variables, okay? Here now I've created one equation with only one type of variable, x's. And whenever you have one equation with one type of variable, you can always solve for that variable. So I can solve for my x. So now I just have to solve for it. I don't like my x's on both sides. So I don't like negative x's personally. I like positive x's, you know, happy, you know, whatever. So I'm going to add x to both sides. How many x's now do I have over here? 2 x's minus 3 is equal to negative 1. Now what would I do? Plus 3, good. Add 3, add 3. So I have 2x is equal to,
Negative 2, I want 2, 2, 2.
it equals 2. Then divide by 2, divide by 2.
1.
X is equal to 1. All right? Everybody gets that?
Yeah. I
Does-
love these.
You love these?
I love
Yeah, they're
them.
fun. They're fun. She's in love. Yes.
Why do we need these in real life?
Yeah.
What could you do?
When I show the word problem, the thing is, there's another method as well that I need to also teach you called the elimination method. And you need to understand that method too before I start giving you word problems.
So,
And once you understand how to solve it, then you're going to start to see real life examples. I can give you an example.
Give me an example.
All right, I can give you an example. Okay, at Una's breakfast boxcar cafe, she sells 4 eggs and 3 pieces of bacon and 2 pieces of 3 eggs and 2 pieces of bacon for $5.22. But she sells 3 eggs and 5 pieces of bacon for $6.52. How much do each cost, the eggs and the bacon? And you can figure it out with with a scenario like that. They're really, really useful. Many, many word problems can be solved with systems of equations, where you actually write 2 equations and then you find that place where they both connect, right?
But so like if we're like out in like world and we want to use the equation, will we have to go to you for a math session?
Yeah, because we'll forget by then.
Yeah, exactly.
No,
I'll be
this
too
is the
lazy
kind
to
of
do it.
thing.
I'll be like,
This is the
"Fine,
kind
I'll
of
just buy
thing.
eggs."
No, you can call Luca up. He'll give you his cell phone number, and you can call him up, and he'll be happy to remind you how to do this. Okay.
Yeah, Luca.
I probably just want to answer.
Okay.
I don't really
Okay.
follow, like,
Now wait. So am I done though?
No.
I need to know a point, but what does a point consist of? It's an x, comma, y. I only know my x. Oh shoot. How am I going to find my x?
Wouldn't it be
You already have it.
y equals x parentheses 1?
Yeah. Look, I can substitute it into either of these 2 equations. Doesn't matter which one. I choose always the simpler of the 2. To me, this one looks simpler because there's less negatives. Don't you agree with me?
Yeah.
Doesn't that look simpler? So I'm going to substitute that in. I got y equals x minus 3. Since I know that x is equal to 1, I'm going to replace that x with 1. So y is equal to 1 minus 3. So y is equal to what?
2. I mean, negative 2.
Negative 2. It's got to be negative because you're taking a bigger number away from a little number. So it's got to be negative 2. So there's my answer. I can either write it like this, x equals 1, y equals 2, or I could write it as a coordinate point. I could say 1 comma negative 2 in parentheses. So any of those ways is fine. Does that make sense? Yes, right? It's pretty easy. Really pretty easy. So let's go back through it and see review what we did. We looked for an x equals or y equals. In this case, it was y equals. We circled what y equals, and we realized that this not only equals this y, but this is the same thing as this y. So I circled this y in the other equation, and I substituted it in for it, and got this at one equation with only one type of variable. Solve for x. Then I substitute that into either of these two equations. I would have gotten the same thing no matter which equation I use. Okay, and I got a y, and I'm done. You can either circle those or write it as a coordinate point. Either one. Okay? Piece of cake, right? Remember these from last year? Good. Awesome. All right, so can I erase?
Yeah.
Let's do another one really quickly. Sometimes one of them doesn't say y equals. I'm going to do one that shows you that in terms of how to do it. So what if I gave you x plus 4y equals 6 and x plus y equals 3. So I have two equations, and my number one thing is one equation must say x equals or y equals. And it doesn't. So I make one of them say it that way. So all I have to do is subtract something from both sides, right? To move something from one side to the other, or add it to both sides to move it from one side to the other. In this case, I think I like to make my y equals when I can. Doesn't really matter. I could do the x equals. Which would you want? X equals or y equals? X equals. Shall we do an x equals and try that one? Let's try that. All right. So how could I manipulate this second equation? What? Well, wait. I just want to say x equals. What's in the way of it saying x equals?
Y equals.
The y. And what did the y do to the x? But what did the y do to the x? It's adding to the x. So I have to subtract y from both sides, right? So that gives me x equals, I'll just say 3 minus y. Okay? You agree with me?
Yeah.
So now that is the second equation. So now I see x equals, this is the same thing as x. Yes? All right, so now since I got this from this equation, I've got to go up to the other equation, right? And since I found out what x equals, I've got to circle my x. And I am going to replace that x with this. So get it? You get it?
Yeah.
Right? So immediately I write this, 3 minus y plus 4y equals 6. And look, all I have is y's. That's awesome. I just replaced that x with 3 minus y, and then plus 4y equals 6 equals 6. So what is 4y minus 1y? Yes. Okay, Sarah. Wait, but look, they're both on the same side of the equal sign. Can't I combine them?
It should be 3y?
If I added y to both sides, then I'd have a y over here, and I'd have y's over here, and then I'd have to subtract them again. I want to combine these. Can't I combine those?
Yeah, you can combine them.
4 y's, and somebody took away one of them, so I have 3 y's. So I have 3 plus 3y, right? You agree with me?
Yeah. How?
Because-
there's not a y on the other side.
Because this is a negative 1y,
Oh. So that's
and this
one.
is a positive 4y. 4 y's minus 1y is 3 y's. Does that make sense? You see that? Right? Because, so I have 3 plus 3y equals 6. And now, let's see, I'll get rid of the 3, subtract 3, subtract 3. 3y is equal to 3. Divide by 3, divide by 3. Y is equal to 1. Okay, I found my y. How do I find my x? Luca, how do I find my x? Wipe that silly grin off your face, boy. How do I find my x? I take this
Plug it in.
and plug it in. Which one would be
Y.
easier?
Uh,
I think
Y.
that would be easier, wouldn't it?
Yeah.
So let's do that one. So we got x plus y equals 3. And I'm gonna, so x plus 1 equals 3. Subtract 1, x is equal to 2. So I could say those are my answers, or I could say 2 comma 1 and put that in a box, and that's my answer. Get it? Just to 5, you get it? Make sense? Awesome. All right, so that's what we're going to work on tonight for homework, not the graphing. The graphing, you just have to understand. You guys all know how to graph. You graph this one, and then you got a point that you think is the answer. You have to check it and see if it is the answer.
Wait, I'm just like.
But we're not going to do the
Can
graphing.
you do my homework for tomorrow?
And what?
My homework for tomorrow.
Is it due tomorrow?
No, can I give you the one that was due this weekend? 'Cause I don't want.
Tomorrow, yes.
No, can I give it to you?
Did I give it
Right
back
now.
to you? Did I give it back to you?
Or can I give it to you? Like, if you keep it to me? Can I give you the homework for you to keep till tomorrow?
This is so confusing. Do you mind if I turn off the video?
Yeah.
You're